afternoon and welcome to Vic Gardner's Office Hours Measurement of Effect Coatings. We have Corey Cohen here today, our application specialist, and he will be presenting a short presentation. If you're not familiar with our office hours format, he has a short presentation and then we will open it up for questions. You can put your questions in the chat. Just a reminder, we are recording. And when we do get to the questions section, Corey will be able to answer your questions or do the best that he can. Feel free to try to stump him. We also have our very knowledgeable business line managers that are in attendance as well, and they will also assist Corey with answering some questions, so you may hear them chime in as well. Thank you so much, and I'm going to turn it over to Corey.
Thank you, Sherry. Today's topic is on measurement of effect coating. So as usual, I'm going to hit just the broad strokes, and then I will send it over to you guys to ask some questions and let us know what you want to learn about today. Sorry, 1 second. There we go. Already. Okay, so when we talk about effect pigments, what we mean are non-absorption pigments. So absorption pigments, first off, are pretty much those typical everyday pigments. Whenever someone just says pigments, that's typically what they mean, absorption pigments. And their job is to absorb certain wavelengths when light is shined on them and reflect certain wavelengths, and that's what gives objects their color. So due to the chemical properties of these absorption pigments, those are the things we add to various objects, plastics and paints and dyes and things that give everyday objects their color. So the normal everyday pigments we typically talk about, those are the absorption pigments. The effect pigments are sort of specialized pigments that give these specialty effects, these visual effects when we look at them. So two examples in particular that we deal with quite often are metallic pigments, and that tends to be things like aluminum flake, little bits of aluminum that can be in a coating, for example, on a car, a boat, or a plane. And those give kind of a sparkly effect to a coating. Makes things kind of sparkle when under direct light, like sunlight. Another type of effect coating are pearl luster pigments or pearlescent pigments. And these pigments have special properties where they sort of are transparent to certain wavelengths and are reflective to other wavelengths. And the effect that has on the macro level is it can actually change what the color, it can change the hue that we see of the color depending on the viewing angle. So with these types of pigments, pearlescent pigments, we actually get this interesting sort of color changing effect depending on the viewing angle. So these are the types of pigments we're going to talk about measuring today. So because these effect pigments have a different effect based on the viewing angle, it's necessary to measure them at multiple angles. So this is representative of the setup for a multi-angle color instrument where you have a light source, the light coming from one direction, so it's a directional light source, and then the measurement is done at multiple angles to capture the color change effect, either the color flop effect, which is where the color changes depending on viewing angle, or the light dark flop effect, which is where the apparent lightness of the surface changes depending on viewing angle. So in order to make sure that two surfaces match under all angles, not just one, it's necessary to measure those surfaces at a bunch of different angles. And here's why. So hopefully everyone is familiar with a spectral curve or a spectral reflectance curve. This is the raw data that's being measured by a spectrophotometer when you use a spectro like our Spectra 2 guide or our BICMAC instrument to measure the color of a surface. What it's doing is it's shining white light on the surface, and it's measuring what percentage of light reflects back at each wavelength between 400 and 700 nanometers, the visible range. And so what we get is a spectral curve that looks like this, that tells us what the color is. So for example, if a color reflects lots of blue light, blue wavelengths, those very short wavelengths, and absorbs most of the longer wavelengths, that's a blue color. If it reflects most of the red wavelengths but absorbs all the shorter wavelengths, that's a red color. This right here, what we're looking at, this is reflecting, we can see here, I'm going to activate my pointer. We can see here it's reflecting lots of light in this green range right here, and it's absorbing most of the light in these other ranges, and so this is a green color. Now what we're seeing here is actually multiple spectral curves, because this was measured with our BICMAC instrument at these 6 different measurement angles. We're seeing 6 different spectral curves here, but they are right on top of each other. They're pretty much all the same spectral curve, no matter the measurement angle. And that's because this is a solid green color, solid, indicating that this coating only has absorption pigments in it. So no effect pigments, just absorption pigments. And with absorption pigments, typically we're not going to see much of a difference based on the viewing angle. We're going to see pretty much the same color, as long as we're not looking at it at the specular angle. We never want to evaluate color at the specular angle. But at pretty much all the other angles, we're going to be seeing the same thing, and that's reflected here in these curves. They're all right on top of each other. So for a solid color like this that only has absorption pigments, we don't really need a multi-angle spectrophotometer. We don't need to measure color at multiple angles. Just one is typically good. We can use the 45-0 or the sphere for measuring a surface like this. But now we're looking at a metallic green color. And again, we have our multi-angle color measurement where we're measuring at 6 different angles, and we have 6 different spectral curves. And these are pretty drastically different from each other. And this is why we do need for metallic colors to measure at multiple angles, because we're going to see different things at different angles, just like the BICMAC, the multi-angle measurement color measurement instrument. Is going to measure a different color at multiple angles. So this is why you want to measure at multiple angles, so that when you're trying to match 2 surfaces, when you're matching a standard, when you're matching neighboring panels on a car or something, you want to make sure they match at all these angles, not just one angle. Because if you use a single angle spectro, you might, that spectra might say that these 2 colors are exactly the same, they're a good match, and then you move to a different observation angle and they're a really poor match suddenly. So it's important for metallic colors, which is one of these effect pigments we're talking about, to measure using a multi-angle spectrophotometer. And so here with these spectral curves, we can see that they have the same general shape. We're getting lots of absorption in most places except this green range. So again, this is a green color. It does still have green absorption pigments in them. But due to that metallic flake, the lightness is changing depending on the viewing angle. We're getting some of that light dark flop. And that's why, even though these curves are the same general shape, the overall reflectance level is changing depending on the viewing angle. So we can see that as we get further from the specular, so these angles give the measurement angle from the specular. And as we get further and further from the specular, from the 15 to the 25 to the 45, as we get further, that color is going to look darker to our eye. So that's light dark flop. And then here we have a somewhat more drastic example of light dark flop in this metallic silver. So I want you to note the vertical scale on the left for the percent reflectance. So with the metallic green, we can see the percent reflectance relatively low. This is a relatively dark color at any angle. But then we switch to metallic silver, and that reflectance level jumps up. So this is at certain angles going to give us a very, very bright look, and at other angles, it's going to look very, very dark. And that's often why you see silver on very curvy, kind of nice looking cars. Not just because silver is a nice looking color, but because when you have a very curvy car, that means those curves, your eye is going to see different parts of those curves at different angles, And this light dark flop effect is really going to help accentuate those curves. So here we're getting this really drastic color flop when we change viewing angles. So again, another great example of why we want to measure our color at multiple angles, not just one. So in addition to causing this light dark flop effect, what we also get with these metallic pigments is again this sparkle effect, this glint, this kind of this diamond look, however you want to describe it. This is something that happens only under direct lighting conditions, so it wouldn't happen quite as much if you're looking at it under diffuse lighting, under like a cloudy sky. Um, but under sunlight, when you have a metallic coating, a metallic paint job, you're going to see that brilliant sparkle. And again, this is something that you're going to want to control from surface to surface, because when two surfaces have different sparkle levels and they're right next to each other, that can become very obvious to the eye. So when you're trying to match a color, make sure that your color matches the standard. It's important not just that the base color matches, but that the level of sparkle, both in the amount of the little sparkle pigments and also the brilliance, the brightness of the flash that you're getting off of those sparkles, you want to make sure that they match from surface to surface. Another effect that you get with these, that you sometimes get with these metallic pigments, an undesirable effect, is this grainy look. We call it graininess. This is kind of it's described as a salt and pepper effect, or a coarseness or a texture that we see sometimes in these metallic coatings with these effect pigments. And it's something we don't really want to see. So it's good to control for that also, to make sure that you're not getting too much graininess in your surface under diffuse lighting conditions. And so again, when you take measurements with a spectrophotometer, if you're measuring these effect pigments just with a spectrophotometer, just measuring the color, the spectrum might tell you that the color of these two surfaces is the same, and yet they might look different because of the difference in the sparkle in particular. So it's important not just to control for the color of the surface, for the color of the base coat, even at multiple angles. That's not going to give you the whole story. You really want to evaluate separately the sparkle as well. Um, and so our BICMAC instrument does that with illumination at 3 different angles. When you're talking about sparkle, really the important thing is the direction of illumination. So when we're talking about color flop or light dark flop, it's the viewing angle that's important. When we're evaluating sparkle, it's differences in the illumination angle that can actually cause differences in how we see the sparkle. And so you want to look at your surface under multiple illumination angles to make sure that it's going to match, no matter where the illumination is, where that sun is in the sky, or whatever. And so we have these 2 instruments for evaluating effect coatings. On the left, we have our BICMAC I instrument, and this is the instrument that measures multi-angle color at 6 different angles to make sure that your color looks the same at all angles. It accounts for that light dark flop and that color flop effect. It also separately quantifies the sparkle and the graininess of the surface to make sure that your sparkle matches from surface to surface, from panel to panel, and to make sure you're not getting too much graininess, and you can minimize that as much as possible. On the right, we have a light booth. This one's called the Biko Spectra Effect. And this light booth is specifically made for effect pigments. So with most light booths, you evaluate your colors under diffuse lighting. But again, that doesn't work so well for effect colors because that's going to eliminate the differences that you'll typically see with viewing angle. You want to really see your effect colors under direct lighting, like you usually see them in natural conditions. And so this light booth actually allows you to view, it has a rotating sample platform that allows you to rotate the sample through different viewing angles. It allows you to view your colors exactly the same way the Big Mac measures them. It also has different illumination angles, so you can evaluate the sparkle of your surface. So these two are sort of a companion for each other. On the left, the Big Mac eye for getting that instrumental measurement, getting your color numbers, and then on the right, the light booth, the Biko Spectra effect, so you can see everything with your own eyes exactly the way the Big Mac is measuring. So that's what I have for you today, and I will toss it back to Sherry so we can take some questions.
I don't see any questions in the chat yet. Does anybody have any that they'd like to put in? Maybe you're struggling with, something, or we're unsure of something maybe Corey said. Feel free to type away. I think someone is typing, so we'll just wait another moment. We have some questions coming in. So, is the Big Mac useful for non-effect pigmented surfaces as well? Example, standard color absorption pigments.
Yes, so the Big Mac is often used to measure absorption pigments as well, just regular coatings with no effect pigments in them. Again, the 6 angles is not necessary for that, and so typically when measuring solid colors, those additional angles will be turned off, and typically just the 45-degree measurement angle is used because that coordinates with the 45-0 geometry that's commonly used for measuring solid colors.
Just from a business line perspective, so I mean, I do automotive. I can tell you that the newer pigments, even in solid colors that are coming out with clear coats, are starting to travel. So a lot of the OEMs have started changing to add the 15 through the 110, even for solids. Just a comment.
Thank you, Ray. Kevin, I hope that answered your question. Yep. So, Corey, how does the distance affect how I see sparkle?
So I'm going to say that sparkle is the differences, particularly in sparkle, that you might see would be more apparent close up than further away. Typically, if you want to get a really good look at the sparkle, you need a pretty close viewing distance.
And I assume that height has something to do with it as well, and how you view it.
So, and from my perspective, I mean, the color in general, depending on how close or far away, you're going to see things differently. And like you said, Sherry, how tall someone is versus someone shorter is going to see a different angle. So it's all important to see the total color of the material you're looking at.
And Oliver is asking, was the solid green at the beginning glossy or matte? I'm not sure if you can flip back.
It was a glossy, solid green.
We also have a question. Is there a way to scroll down by page or to go to the bottom on the Big Mac eye? Sometimes I have 200 plus standards. It's an instrument specific.
Can you unmute him? I need to ask a couple questions. We probably need to send someone in, and I don't think they're organized in the best way.
No, I'm going to undo your microphone. I believe I turned on your microphone. No, do you have microphone? Able to say something?
If not, Noel, if your microphone doesn't work on your computer, that's okay. But I mean, just send Sherry an email at the end, and then she can forward it to me, and we'll help you get that all situated out.
Yeah, and I'll be able to note that.
Okay.
Yep. When characterizing a sample, which color angle might be better to use as a reference?
Are you characterizing a effect color or a solid color?
Mark, I have unmuted you if you wanted to speak, if you're able to. Oh, he
has a comment. Hold on, I gotta turn the computer over to him.
So if you're trying to characterize effect pigment, the most important information is at the 15 and minus 15, maybe a little bit at 25. If you're looking at more of the absorption pigments or the underlying color, then 45 is going to be more valuable in that respect. 75 and 110 will give you more information about process variability.
There is a comment that this is for wood samples, and sometimes it's a solid color and other times it's a clear coat.
Wood.
So wood grain is going to affect your near specular angles. So if you're thinking about looking at a grazing angle, the wood grain will affect how that reflectance information is detected with a BICMAC or detected by the observer.
Does that answer his question? Okay.
Yes, thank you. We have another question. Could this be used for textured or wrinkle coat finishes?
So I'm not familiar with those particular terms, wrinkle coat finishes, but if you're dealing with textured samples, a multi-angle spectra might not help you so much. We do have another instrument. It's called the Spectra 2 Profiler, which has some measurements that can actually characterize the grain, the texture of the surface, and help you control that from sample to sample, because that's really important when dealing with textured samples. Even if the base color is the same, the look of it, the apparent lightness can change depending on the texture. So you want to, in that case, not just control for the base color, but also that texture. And that instrument can help you do that, the Spectra 2 Profiler. So if you'd like to learn more about that, you can reach out to us directly and we can talk about that more.
Thank you, Corey. Thank you as well. Are there any other questions? I believe someone is typing, so maybe there's another question coming in. Please feel free to keep your questions coming. Okay, so we have, what is the overall sample area for a single BICMAC or a Spectra 2 profiler? if, for example, I wanted to characterize a patterned color combination on a textured surface, what would the sample area be?
So we have two versions of the Big Mac. The standard version is a 23 millimeter aperture, so almost an inch. And then we also have a small aperture version, which is a 12 millimeter. Oh, I'm sorry, you asked for the Spectra 2 Profiler. That one has a 1-inch aperture.
Thank you. When using SmartChart to compare samples to a standard, does D sparkle represent an average of SI, SA, and G?
So the D sparkle is the overall sparkle, so it is a combination of the SI and SA. It does not take the graininess into account, no G. It's a little more complicated than just averaging or adding the SI and SA, but it is, yeah, an overall representation of the difference in sparkle that takes into account both those things.
Have a delta SE number that includes sparkle on all three angles and graininess. Just FYI.
That's right. I think there's another question coming in. While someone's typing, I'd love the chance to be able to say, if anybody ever has any topics that you'd like us to cover, you can feel free to either type them in this chat or reach out to the marketing team from any of our emails that we send out, and we'd be happy to include them into our webinars that we do. If you're not familiar, this is the office hours version, and then we do full 60-minute webinars that are more in depth and more of a training session. They usually have an agenda with them. And Corey does those, as well as there's some that get posted on our website. And those are done worldwide, and that's why those are on the website if you wanted to check out and see what's on there. We do have another question. How much does film thickness affect the reading of color? Good question.
See. Film thickness. So the film thickness would really only affect the color reading if the color is not opaque. So if it's not thick enough, then the substrate's going to show through. That would certainly affect the color reading. But yeah, as long as the coating is opaque, it's not really going to affect the color readings.
I have another question. How does the instrument measure technically affect your measurements?
Hey Corey, it was how does the instrument measurement technique affect your measurements? So like how you measure on the vehicle.
Technique.
Or
Okay.
panel.
Sorry about that. Yep.
So
The typo.
with the Big Mac in particular, the directionality is going to be important. I guess two things you could say: directionality and making sure that the instrument is as flat on the surface as possible. So with a solid color spectra, with a 45-0 spectrophotometer, that has what we call circumferential illumination, where you're getting the same illumination from all around. So with those, you can kind of turn the spectro any way you want on the surface, and you're going to get more or less the same reading. With The Big Mac, it is directional by design. So it's not circumferential. The light source is coming from only one direction. And that is by design. That's on purpose because when you're dealing with these effect pigments, typically they will be viewed outdoors, where the light source is going to be the sun. And so the sun, of course, when you're viewing these surfaces, you're only getting that light from one direction. So you want to mimic that illumination as closely as possible, especially when you're dealing with these effect pigments, where the interplay between the illumination angle and the observation angle is so important with the effect that you're getting. So directionality is important. You really want to orient the instrument in the same way for every measurement. And in particular, if you can, you want to orient it in the same way that the sun would be shining. So if you're measuring a car or a boat or a plane or whatever, you want to orient it so that the light source is coming from overhead. And we help you do that with the Big Mac. There is an arrow right next to the aperture on the side of the instrument that indicates the direction that the light is coming from. And so you want to try to orient that so the light is always coming from overhead, because you will get different measurements if you orient it in different ways. If you turn the instrument one way and then another, even if you're measuring the same spot, you can get different readings. So that's important. And then again, you want to make sure the instrument is as flat, the aperture is as flat on the surface as possible, which can be tricky when you're measuring actual products, actual panels, car panels and things that have curvature to them. And so again, we help with that by use of these little pins that are on the bottom of the instrument surrounding the aperture. And those pins will tell you when they are pressed in sufficiently. They'll tell you when the instrument is in a good position for a measurement, and it'll give you a warning if it's not.
Thank you, Corey. Are there any other questions that anybody may have? Anything you'd like to ask on this topic, on another topic? I think there may be another question coming in. Perhaps not. I believe someone is typing, so we'll give it another moment. So I got a warning on my Big Mac that said the surface temperature is over 35 degrees Celsius. Should I be concerned?
So 35 degrees Celsius is within the acceptable range for the Big Mac. So it would still, or it should still at least perform fine at that temperature. But that is actually a feature in the software. You can set a temperature where it will give you a warning. You can actually determine what that temperature is in the software. And what it's telling you is that maybe the surface is hotter than it should be during measurement, and that's to prevent measurement of what could potentially be thermochromic surfaces where the actual color might change due to a change in temperature. Particularly yellows, oranges, reds tend to be more susceptible to this, where the color can change a bit depending on changing temperature. And so there's a typical range you want to stay within when measuring those surfaces. So that's what that warning is. It's actually a software feature.
Thank you, Corey. I hope that answered your question. So, can the instrument be used on any surface, like plastic or glass?
Certainly, it can be used on plastic. If you're talking about plastic without any effect pigments in them, again, it might be simpler to turn off the additional measurement angles. You might not need those extra angles, and so the 45 is recommended, the 45 degree measurement angle if you're only going to use one. Glass can be a bit tricky. If you're talking about transparent glass, maybe colored transparent glass, typically reflectance spectrophotometers don't work great on those. What you could do is try measuring with a white backing, get some sort of backing that that you can take your measurements over. But we'd have to know more about exactly what type of glass you're dealing with and what the transparency level is to tell whether it would work. But the best thing to do if you're concerned about whether one of our instruments will work for you or not, you can always send us samples if possible. We can test some samples for you and see what kind of results we get. Or if it's not possible to send samples, we can possibly set up a demo for an instrument where one of our regional sales managers can go out to you and take some measurements and show you the instrument and see if it's going to work for you.
I can turn on your mic if that, if you wanted to add more to that question, if you meant something different about the substrate, or if you meant it as the actual product. If you have a mic that works, I turned you on. Not sure that we're getting anything else back on that question. Okay. We do have another question. How does the application affect the sparkle and graininess?
I take it you mean the application of the paint, and that can certainly affect the sparkle and the graininess. So typically when dealing with metallic pigments, you want those pigments to lay down sort of in the same direction as the plane of the coating, and that way it's going to reflect the most light, the most incident light on them. And so one issue you can get is if that flake is disoriented, if it's not in the same direction as the plane of the coating, if it's kind of turned at a different angle, that can sometimes result from a dry spray or an overly wet spray. So sometimes the moisture content of the coating when it's being sprayed can affect that. And so typically you would see that in the sparkle numbers if two or if your sample doesn't match the standard for the sparkle numbers, that may be due to the disorientation of the flake. And also that can cause graininess. If the flake is disoriented, that can cause that graininess effect that you see under diffuse lighting. So application is important, and that can often be one of the biggest problems. The other thing that can affect sparkle are the size or the amount of the individual pigments or the reflectivity. So if you're using a different type of pigment or maybe a different quality of effect pigment, that can affect the sparkle. But yes, the application itself, even if you're using the exact same materials, can affect the sparkle. So you want to make sure that it's through those sparkle numbers, you can make sure that your application is as good as it can be.
So application usually affects the sparkle 75 more than the other angles. So if you have an application issue, it's usually on the sparkle 75. If you have material issue, it's usually the sparkle 15. And like Corey said, the graininess can help you figure out what's going on too, if you look at all the numbers together.
In regards to the question about plastic and glass, we do have a comment in regards to surely it will be helpful for inks and pearlescent coatings. Is that right?
Yeah, if you have metallic inks or pearlescent coatings, yeah, absolutely, multi-angle color measurement can be useful for that.
Are there any other questions? These are great questions. Thank you so much for entering them and answering them. As mentioned, we are recording this, so and we post the recording on our YouTube page, so you're able to access. It may be a day or so that gets. Sorry about that. That gets posted, but it will be up on our YouTube page, and I believe a copy of the presentation goes out to you at the end, and then we do have a copy of all of your questions, so we'll reach back out to you to make sure that they were answered sufficiently. Yeah. If there aren't any other questions at this time, we can give you back another 15 or so minutes of your day. You can wait another moment if there are any other questions. And for anybody that's here in the U.S., if we don't speak to you again with the holiday, please have a safe and happy holiday weekend. And I guess, Corey, if you have anything else to add, we could probably sign off for now. Ray, do you have anything else to add either before we sign off?
I think we covered everything.
Okay.
So I think we're good.
Thank you for everybody attending and taking your time out of your day to join us in office hours. Thank you so much.